professor at LG Institutes of Engineering and Technology. So today we are going to discuss a topic named Fourier integrals, right? So let us start with the first topic. So Fourier integrals of f of x is given by f of x is equals to integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega, where our a omega is given by 1 upon pi integration minus infinity to plus infinity f of x cos omega x dx, and b omega is given by 1 upon pi integration minus infinity to plus infinity f of x sin omega x dx. Right? So we just have to find this a omega and b omega and put its value in this f of x to find our Fourier integral. Now if f of minus x is equals to f of x, right? That is, if our given function is an even function, right? Then the value of b omega will be equals to 0 and a omega will be 2 upon pi integration 0 to infinity f of x cos omega x dx. Now if f of minus x is equals to minus f of x, that is, if the given function is an odd function, right? Then the value of a omega will be equals to 0 and b omega will be equals to 2 upon pi integration 0 to infinity f of x sin omega x dx, right? So firstly you have to check whether the function is even or odd, right? Now let us move on to our next topic, that is Fourier cosine integral. So Fourier cosine integral of f of x is given by f of x is equals to integration 0 to infinity a omega cos omega x d omega, where a omega is 2 upon pi integration 0 to infinity f of x cos omega x dx. So whenever you are asked to find Fourier cosine integral, you just have to find your a omega, right? Now let us discuss the next topic, that is Fourier sine integral. So Fourier sine integral of f of x is given by f of x is equals to integration 0 to infinity b omega sin omega x d omega, right? Where our b omega is given by 2 upon pi integration 0 to infinity f of x sin omega x dx, right? So whenever you are asked to find Fourier sine integral, you have to find b omega using this formula and substitute in this, right? So now let us study few examples. So the first example is, using Fourier integral we have to prove that integration 0 to infinity cos omega x plus omega sin omega x upon 1 plus omega square d omega is equals to this given function, right? So what we will do is, firstly we will assume our f of x as this. So f of x will be equals to 0 when x less than 0, pi by 2 when x equals to 0, and pi e raised to minus x when x greater than 0, right? So now the Fourier integral of such type of f of x is given by f of x is equals to integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega. So now let us find the value of a omega and b omega. So now a omega is given by 1 upon pi integration minus infinity to plus infinity f of x cos omega x dx, right? Now we have to split this integration in two parts because our function is given in parts, right? So we will split in minus infinity to 0 and 0 to infinity. But in this interval our function is 0, right? So only we have to substitute the value of f of x in 0 to infinity, and that is pi e raised to minus x. Now this pi will get cancelled out, right? So we have to now apply the formula of integration e raised to ax cos bx dx, which is equals to e raised to ax upon a square plus b square a cos bx plus b sin bx, right? So here the value of a is, compare this with this, so value of a is minus 1 and b is omega. So if we put these two values, we will get answer as e raised to minus x upon 1 plus omega square minus cos omega x plus omega sin omega x, and your limits are 0 to infinity. Now let us put the limit. So if I put e raised to minus infinity, answer will be 0, right? And if I put 0, e raised to 0 will be 1. This will remain as it is. Cos 0 will be 1. So here minus 1 will come. And the value of sine 0 will be 0, right? So the total answer of a omega will be 1 upon 1 plus omega square. Okay. So now let us find our b omega, which is equals to 1 upon pi minus infinity to plus infinity f of x sine omega x dx. Again split your interval into two parts, that is minus infinity to 0 and 0 to infinity. We know our given function is 0 in this interval. So only put value of f of x here, that is pi e raised to minus x. Now in order to evaluate this, firstly take out pi common and cancel out, right? And use this formula, that is integration e raised to ax sine bx dx. So your formula is e raised to ax upon a square plus b square, a sine bx minus b cos bx, right? Again your value of a is minus 1 and b is omega. So put these two values in this, so you will get your answer as e raised to minus x upon 1 plus omega square minus sine omega x minus omega cos omega x. Now let us put the limit. So if you put infinity, right, what you will get your answer as 0, because e raised to minus infinity is 0. If you put 0, e raised to 0 will be 1. So 1 upon 1 plus omega square sine omega 0. So sine 0, the value of sine 0 is 0. So that is gone. If you put here 0, cos 0 will have answer 1. So only minus omega will remain. So if you simplify, final answer of b omega will be omega upon 1 plus omega square. So now let us put our values of a omega and b omega in our Fourier integral, right? So on putting the values of a omega as 1 upon 1 plus omega square and b omega as omega upon 1 plus omega square, right? So we have proved that this is equals to our f of x using Fourier integral. Now let's start with our next example. So we have to find Fourier integral representation of f of x is equals to 1 when mod x less than 1 and 0 when mod x greater than 1. And we also have to calculate integration 0 to infinity sine omega cos omega x d omega upon omega and integration 0 to infinity sine omega upon omega d omega. So now let us start with the solution. Here you can see that whenever we replace x by minus x, you can see our function remains same, right? So from this we can say that the given function is an even function. So our b omega will be equals to 0. So we just have to find the value of a omega. So a omega will be given by integration 2 upon pi. Limits will be from 0 to 1 only, because our f of x is what? 1 and 0 for mod x less than 1 and for mod x greater than 1, right? So now we have to put the value of f of x only in 0 to 1. The value is 1. So f of x is equals to what? 1. So only cos omega x will remain. Now integrate this cos omega x. So integration of cos omega x will be what? Sine omega x upon omega. And your limits are 0 to 1. Just put the limits. So now if you put x is equals to 1, what will remain? Sine omega upon omega. And if you put 0, we know the value of sine 0 is 0, right? So the final answer of a omega will be 2 upon pi sine omega upon omega. So now let us put the values of a omega and b omega in the Fourier integral. So but our b omega is 0. Just put the value of a omega, which is 2 upon pi sine omega upon omega. Now take out this 2 upon pi outside, so we will get 2 upon pi times integration 0 to infinity sine omega cos omega x upon omega d omega, which is equals to f of x. Now take this 2 by pi on this side, so we will get finally integration 0 to infinity sine omega cos omega x upon omega d omega is equals to pi by 2 f of x, and we will name this as our equation 1. So now let us find the other two questions. So we know that our given function is discontinuous at x is equals to plus or minus 1. That is, whenever mod x is equals to 1, our function is discontinuous. You can see our f of x is given by what? 1 and 0 when mod x less than 1 and 0 for mod x greater than 1. So now we will check the value of our f of x at firstly x is equals to 1. So it will be equals to half times limit x tends to 1 minus f of x plus limit x tends to 1 plus f of x, right? So you can see this value will be 1 from the function and this value will be 0, right? So final value of f of x will be equals to half at x is equals to 1. Done? Now at x is equals to minus 1. So here f of x is equals to 1 upon 2 times limit x tends to, now we have to take minus 1 in the direction of minus f of x plus limit x tends to minus 1 plus f of x. So here now this value will be 0 and this value will be 1. So our f of x is equals to half when x is equals to minus 1. So here we have got our value as half whenever mod x is equals to 1. Okay. So now let us move on to our next step. So our equation 1 is this, that is integration 0 to infinity sine omega cos omega x upon omega d omega is equals to pi by 2 f of x, where our f of x is 1, half and 0 for mod x less than 1, for mod x is equals to 1 and mod x greater than 1. Just multiply by pi by 2, so your answer will be pi by 2, pi by 4 and 0 for mod x less than 1, mod x is equals to 1, mod x greater than 1 respectively. Now we have to obtain the value of this, right? So in order to obtain this value, we will just replace x by 0. So in equation 1, just put x as 0. But we know the value of cos 0, that is 1, right? So if we put 1 over here, we will get our final answer as integration 0 to infinity sine omega upon omega d omega pi by 2 times f of 0. But 0 lies in this interval, right? That is minus 1 less than x less than plus 1. So our f of 0 value will be what? 1. So our final answer of this integral is what? Pi by 2. Okay. So using Fourier integral, we have to prove that integration 0 to infinity 1 minus cos omega pi upon omega sine omega x d omega is equals to pi by 2 from 0 to pi and 0 for x greater than pi. So this is our given function. Now in this you can see from this term that we have to find Fourier sine integral, right? So we have to use the following formula, that is f of x is equals to integration 0 to infinity b omega sine omega x d omega. So now let us start finding our d omega. The formula is 2 upon pi integration 0 to infinity f of x sine omega x dx. Just put the value of f of x firstly. Split the interval in two parts, that is from 0 to pi and pi to infinity. But in this interval our f of x is 0. So just put over here pi by 2, this sine omega x will remain as it is. Now you can see these two will get cancelled out. Just integration of sine omega x will be what? Minus cos omega x upon omega and your limits are 0 to pi. Right? Now let us put the limits. So if you put pi, it will be minus cos omega pi. Now minus and this minus. So plus, if you put 0, cos 0 will be 1 upon omega. So final answer of our d omega is 1 minus cos omega pi upon omega. So now let us put this value in our Fourier sine integral, right? So in this, put b omega as 1 minus cos omega pi upon omega. Done. So final answer we have derived is integration 0 to infinity 1 minus cos omega pi upon omega sine omega x d omega is equals to what? F of x, and this is equals to what? Pi by 2 in 0 to pi and 0 when x is greater than pi. So I hope you have understood throughout the session. Thank you for watching.